So let me ask a question to start also the process. So Anuj, I would like to ask, so I saw that you have this also soft error in 3D chiplets. Is it feasible to adapt Comet Simulator also to consider like soft error reliability and see how this have these flip bits in the memory stacks?
So not off the shelf, but this is something on our agenda in our roadmap to actually have this implemented, like to flip bits both in memory and in the processors using fault injections. This is an ongoing work. And we want to link it to the thermal. So hotter the particular part of the chip is, higher would be the probability of the fault injection being successful.
Okay. And actually, one question to Alberto also. My question was how much is the manual of the engineer that has to create this higher 3D? So I saw that it has a lot of in-house and industrial tools. So is it easy to adapt from 2D directly to 3D integration based on this hard 3D flow or?
So, yes, actually, I believe the key point is the fundamental ideas. Later on, the adaptation and implementation are not so complicated. So we have two levels. One is the level of the set of scripts which are required for the system, let's say, to the fundamental run. And this is relatively simple, and I believe it can be easily replicated. The other part is the additional algorithms which are required for the part of the floor planning. This part is a bit more critical, but with this exception, I believe the replication for other tools, for open source tools, is something that will be very interesting to do, and I believe hopefully will be one of our next steps.
Okay, thank you very much. So, are there any other questions? Yes, I see. Thanasis, yes?
Yes, hello. First of all, thank every one of you for these presentations. They were informative. I would like to ask some general things. My questions are not directed to some specific person. Alberto, Anu, and Olympia may all answer. My first question is, do you know why it seems that industry is a bit hesitant to adopt 3D for planning technologies in their tools? And the second one is those tools that were presented to us today, since they are planning or on making space for 2.5D or 3D chiplets, do they require significant more processing time, or do they have large computational requirements? These are the two questions.
Thank you, Thanasis. Maybe Anuj or Alberto or Olympia, everybody.
Maybe one part of the answer from my side. As far as I know, I believe the key players in terms of CAD, they are doing a huge investment and huge research in terms of algorithms for addressing 3D. The problem is that 3D, place and route, synthesis, and so on, is relatively easy when you consider simplified problems like sequential 2D, but it is extremely challenging when you address systems where you try to do chiplets analysis or multi-tier with heterogeneous. So I would not say that they are hesitating. I believe the point is that they are strongly researching in that area. And definitely, this will require to rethought a lot of the 2D tools that we have right now, because a lot of, let's say, the metrics, the cost functions that we are using are inappropriate in this scenario. But probably, Olivia, the other colleagues have another opinion or...
Actually, I will mostly say the same as Alberto did, so you mostly covered me. But what I would say is that in general, what we see from the industry part is that industry is quite conservative. Academia moves faster into more newer things. So I think that they need to research, as Alberto said, more in order to trust the new things, you know. So I think that we will most likely see this in the following years, but I think there is some time for the industry to go to this direction, to adopt them, and to be convinced to adopt them. So yes.
I see. Thank you very much. I don't know if Anuj has to add something else. Both of your answers make sense to me, actually. I know that there is a lot of research going on right now in academia, but I have not seen any, dedicated tools that goes end-to-end 3D floor planning. Perhaps it's what Olympia suggested. I'm not sure. I would also like to ask something else regarding the 3D. Some partners here showed us some simulators. On a general sense, does 3D integration impose several problems in terms of thermal power distribution of a grid to the point that it is almost impossible to achieve? Or are there some methods to efficiently dissipate heat? Because in my mind, when you design a 3D, not 2.5D, a 3D design, a 3D chiplet, let's say, the power dissipation is very hard to achieve, right? Like really hard.
Yeah, so I think one of the main reasons which stand in the way for the adoption of 3D technology is probably thermal. So, so as you said, heat and power dissipation is very difficult. So we don't have very good solutions for this from industry yet, but there have been solutions in research that has been proposed, that they use 3D microfluidic cooling, which runs along with TSVs, which are providing the communication between the chiplets. So there are exotic technologies to achieve this. So thermal is still an open problem to be solved, and 3D only makes it worse. So, and beside that, also regarding your last question, I think economics is also very important for industry. So it is not necessarily that something that has been shown to be a proof of concept will be adapted by the industry in the real world, because it has to be also produced financially viably and should scale, and the production should scale. So Intel did produce 3D chips. I think they came up with a based on Floros technology, they came up with a processor. I think it was called Alder Lake, maybe more than a decade ago. But the processor itself was so expensive that nobody wanted it. And it was only produced in a very limited production because of very limited yield. And of course, if a processor is produced in a very limited quantity, then the associated cost of manufacturing, maintenance, design, software support becomes all too much expensive for a particular design to continue. So these are some real world constraints which industry also has to take into account.
I see. Thank you, Anuj. Thank you very much for your answer.
Thank you. I think there's another question on the Q&A. Let me. So one question, I think, for the entire for all the speakers is: are you in the contact with any foundries to update relevant aging data for open source project, or is it pure physics model based?
I don't know if this goes to electromigration, to my talk, but I will answer. And of course, if any other speaker wants to answer, by all means. So foundries and in general, industry, they are not very reluctant to give out results that they have done through experiments or on their models, designs, etc. It is quite difficult for the NDA, especially as you go to lower dimensions, to newer technology nodes, to process nodes, like 3 nanometer, 5 nanometer, the cutting edge. So it is quite difficult to obtain this. However, there have been some research done around it on how to tune these physics-based models for electromigration. And if I'm not mistaken, currently in the industry, some industrial partners are collaborating with academia in order to achieve this, and in order to get rid of Black's model, the mean time to failure Black's model that is currently used. So yes, for the model that I personally showed, we have not been in communication with any foundry, but this is the base, and one can take the model, a company can take the model and test them themselves and tune them in order to accurately use it. But also all the other speakers can speak for different research topics.
Yeah, so we work on a much higher level of abstraction than foundry. So the companies we talk to are basically computer architecture companies like Intel, AMD, NVIDIA, ARM. So again, here due to security reasons and proprietary reasons, they don't really, this data is generally don't release. So what you can do is that you can send, for example, we have shown our heat maps of our simulations to these executive under the companies, and under NDAs, they have kind of revealed that our heat maps are for the 3D processors are in the same ballpark figure they observe in their own labs. And I think, and they probably don't want to say anything more than this. So this is the contact we have. There is the risk of having too much contact with the industry under an NDA, because then you may have a lot of information, but you may reach a point where you can't publish anything based on that information, and it becomes complicated very fast.
Understandable. Thank you very much for your answers, both of you.
Thank you all. So is there any other question? No, so I would like to thank you all the speakers and the participants. So we will upload the webinar also in our YouTube channel, so feel free to check it out when it is uploaded. So for that time, I would like also to conclude this webinar, and hope to see you in our next webinar also.